Hey, welcome to the YouTube videos for the Combinatorics quiz review. If you've had the chance, I would go through and read that first page just to know the descriptions of what's going to be on the quiz. And then these videos are just going to work through some of the examples of what's going to be on the quiz. The small topic for the quiz is uniform and non-uniform probability distribution. And this is actually pretty straightforward. If you have a scenario where each outcome is equally likely, it qualifies as uniform. So equal probability. And I would say, non-uniform would be cases where you have non-equal likelihood of each outcome. Non-equal or unequal probabilities. We'll go through these situations here, whether or not they qualify as uniform or non-uniform, and then we'll just take these couple of brief phrases and we'll write a more specific description here. So flipping a coin. Sometimes you get heads, sometimes you get tails. Do you get one more than the other? No. The chances of getting heads, the chances of getting tails are equally likely. So we're going to call this a uniform probability situation. Let's just label it up. Selecting a random month of the year. So here there are many more results, right? It could be December, it could be November, it could be August or May. Technically, if it's random, there's 12 months. And if it's completely random, there's no reason one month should be more probable than another. Obviously, if you start picking random months, you can have a scenario where a month happens more often or another month happens less often. But in terms of probability, in terms of what we expect each month to be equally likely. So this is another uniform probability situation. Which hand you write with? Well, if you select someone at random, perhaps they're left-handed, perhaps they're right-handed, or perhaps they're ambidextrous. We have multiple results. Almost everybody is right-handed. It's a very large percentage of the population. So if we select somebody at random, the chances for left-handed, the chances for right-handed, they're not equal. Or in other words, they're non-uniform. So we'll use NUP to represent non-uniform probability. The results of a single-sided dice, right? There are 6 sides of each dice. When we play a board game, we want to roll a high number, but our chances of rolling a high number, our chances of rolling a low number, they're always equal. So this is a uniform probability scenario. However, the sum of multiple dice, I don't know if you guys remember this, but when we did a probability distribution table for dice, and we had sum, and then we had probabilities, certain sums, like adding up to 2 or adding up to 12, were less likely. And I don't know if you remember this, but 7 is the most likely sum that you'll get when you roll dice. So because certain results are more likely and certain results are less likely, this is non-uniform probability. We'll give it that NUP label. The color of a randomly selected playing card. There are 52 playing cards. Half of them are black, half of them are red. So this is kind of like a coin flip. You have a 50-50 chance, regardless of if you're trying to draw a black card or a red card. So this is a uniform probability scenario. This one, I guess, requires what's called institutional knowledge. You do need to know a little bit about DSA, but I was kind of hoping that most people could guess this. If we randomly select a student in the high school, the probability that if we randomly select a student at DSA, the probability they're in high school is greater and the probability they're in middle school is less. There are more high school students here than middle school students. Hopefully, if you didn't know that as a fact, just you have enough common sense to kind of recognize that we have 4 grades of high school and 3 grades of middle school. So this is a non-uniform probability scenario. Because you're more likely to get high school, you were less likely to get middle school. They're unequal probabilities, so it's non-uniform. Identify 2 scenarios labeled up or you labeled uniform probability. Why do they fit this description? Let's do an easy one. We'll do flipping a coin. And then we'll also do, well, let's do results of a single-sided dice. Okay. So flipping a coin. What makes a uniform probability? Heads and tails are equally likely results. I'm running out of space here, but we'll do the results of single-sided dice. Each side, 1 through 6, is equally likely, or we can actually give that a probability. We can say has a 1 in 6 chance. Every side of the dice has a 1 out of 6 probability, so they're all equal probabilities. That's what makes it uniform. All right, let's look at some that we labeled non-uniform probability. Let's go with which hand you write with. Let's do this one. And then let's do middle school, high school at DSA. So handwriting. It is more probable that a selected individual is left-handed. I know I'm not really writing very clearly today with a marker. I apologize for that. Hopefully you have the volume turned on and these descriptions are clear. I'm kind of out of space to write a description for high school or middle school, but something like if you select a student at DSA, you are more likely to select a high school student, or you are less likely to select a middle school student. Any description like that would be satisfactory to explain why it's non-uniform probability. So that's uniform and non-uniform probability. That's all we really need to know. If the scenario is described to you, you just have to think about whether or not results are equally likely. Or if you're presented with actual data, what you're looking for is equal probability numbers. If, for example, if you do a probability distribution table, if all of these values are the same, it's uniform. If you have different probabilities in your probability distribution table, it's non-uniform. So it's a determination you make if you have data, or if someone describes a scenario, you just use some common sense, like flipping a coin, or which hand you write with to decide whether or not results are equally likely. The majority of the quiz is on Combinatorics, which is the next few videos. Please go ahead and click on those. Thank you for watching. Email me any questions that you have.